Welcome to Pain Points. I'm incredibly excited about today's episode. I'm speaking with Professor Mike Levin, Director of the Allen Discovery Institute at Tufts, and, in my opinion, the most interesting scientist alive. He's created devices to regenerate limbs in animals that are non-regenerative, made tadpoles grow working eyeballs out of their tails, and created other novel, self-healing, microscale life forms. I'm joined also by Adam Saffron, who's a postdoc and collaborator with Mike Levin, and who is a good friend of mine. The discussion was really dense, so I want to give a bit of context before the whole interview begins. It's actually taken me a couple of months to understand the basic ideas of Mike Levin's worldview, and I'm going to do my best to summarize that in a couple of minutes for you here. So the big idea can be compressed into a single phrase. Every living thing is a collective intelligence. He lays this out most clearly in his paper, A Technological Approach to Mind Everywhere, which I'll link in the show notes. And we refer to that with the acronym TAME, T-A-M-E. So the basic idea is that we often think about our larger selves as having goals and solving problems to achieve those goals, having agency. But the emphasis that Mike Levin puts is that we and all living things are made of things which have their own goals. And this goes all the way down. So before getting to an example, just to clarify what an agent is, in this case, we're borrowing from the literature of cybernetics, from computer science in the 1940s or so, where the agent is defined by its goals and stressors, where both can be understood in terms of states. So the simple example that we can give is a homeostat. So if you set your house's temperature control to 70 Fahrenheit, we can say that its goal is to preserve that state. It detects deviations if it's warmer or colder, and can activate the heating or the cooling to allow the room to return to that state. In that sense, it's a basic agent. We can use a similar analogy to talk about humans and people. When you're hungry, you want to minimize the stress of hunger and return to the state where your stomach is neither too empty or too full. But we can also talk about this at the level below us. Our livers have a certain biochemical balance that they want to preserve, and they detect deviations from that state space, and they take actions like produce a certain enzyme or other biochemicals to return to that set of states. And note that I'm using the homeostatic metaphor here just for simplicity, but it can get a lot more sophisticated than just returning to a set point. The set point idea is limited on its own. But okay, so you have this goal of not being hungry. Your liver has this goal of keeping this biochemical, this pH balance, for example, or a certain amount of glycogen in your body. But even your liver cells have their own goals. So your liver cells have goals of replicating DNA faithfully, reproducing in their own right. Even the subcomponents of the DNA, such as the microtubules, you can frame as having their own goals. So the idea here is that we're nested and all these agents are dancing harmoniously in this big orchestra. So that is a really deep idea that has not at all been internalized in biology and drives a lot of Mike Levin's work with bioelectricity and regeneration, and I'm really interested in it for pain and health more generally. Having laid that basic context, now we can talk about some of the quick points that Mike makes in this interview. So one of the more mind-expanding points he makes is that we can understand persistent patterns themselves as agents. And this is honestly really radical, and I was just continuing to cycle on it during the whole interview, but I just laid out for you, it is hopefully fairly intuitive how you can understand yourself as an agent and also how your liver can understand itself as an agent. But the idea here was that the pattern chronic pain itself, which doesn't have a physical embodiment, we can understand as having goals and taking actions to achieve those goals. And so we elaborated more on the interview, but the idea that you could have this non-embodied entity with its own goals is really interesting and provocative here. The second thing that he mentions is about belief and regeneration. So he says, failure to regenerate is a false belief that they're not going to be able to regenerate. And to illuminate that a little bit, I think it's hard to understand without some prior context, is to think about cancer. So the TAME framework helps you understand cancer not as some mysterious ailment, but as basically dissociative identity disorder at the level of your somatic cells. What's happened here in the TAME framework is that a group of cells, say around your liver, have stopped believing in the story of you. They've stopped believing in the story of you and decided no longer to sacrifice themselves to be, part of the lower part of the liver, and instead just replicate selfishly. So that's what these cancer cells are. They are your cells, but they don't differentiate into the helpful function that supports you in your life. So this is how you can get a sense of the flavor of cells and clusters of cells having beliefs. And it's really, things start to really make more sense when you think about that. Anyways, there's a lot more to unpack, but to really dive into it, you'll want to read the TAME paper itself. But without further ado, I'll get started. The context of this is involves a little bit of a personal story, but I'll keep it brief, how I came to this research. So a few years ago, I was a grad student at MIT using model-based and model-free RL to study how humans solve puzzles. And then I found that as I was working one winter, my hands started to really hurt and seize up. And I went to MIT Medical. The doctor and the specialist he sent me to gave me an explanation in terms of my hardware, the tendinitis, RSI, whatever. And things began to get worse and worse until I basically couldn't functionally type or open doorknobs. And it was for a couple of months that I was really confounded. What is happening here? And it was really confusing because I'm quite an athletic person, and it was only like a couple months prior that I was able to do pull-ups and whatnot. And so the short of it is that I started to experiment a lot with different interoceptive things, like sensing into what the sensation is, getting more precise about that, and also to some extent exploring the memories that came up. And that was what effectively let me resolve the pain condition. And I was so astounded by that I basically reoriented my research. And I really just wanted to understand what was going on, because it was bizarre to me that I didn't have an accessible explanation. And of course, as I started to talk to people like Professor Fan Wang at the McGovern, she was like, yeah, of course that makes sense. Your nervous system is implicated in your pain. But I still really felt that we don't have good, really clear models besides this vague idea of biopsychosocial things being implicated. So having come from cognition, I naturally tended towards this predictive processing, active inference lens. And it's really helpful to think about pain as some sort of a trapped prior, especially chronic pain when there's no structural damage. And I'm mentioning this because I feel like it gives context for how I'm orienting towards this in a very pragmatic and personal way, but also just to express that the ideas of both Friston and yourself actually really transformed my Umwelt and my felt experience, because having clarity on what was happening actually just changes this like cognitive prior that changed a lot of other things. And so the thing that I think would be really cool to explore with you both is just this intersection between the somatic cognition and pain. And yeah, it was through my interactions with some of the active inference researchers that brought me to Alexei Tolchinsky. Actually, after one of the blog posts that you put up, I reached out. And then Adam, I met at a conference, and there was a clear synergy, and I think we both just enjoyed each other's energy a lot. There's a bunch of things I'm interested in exploring, but I thought I can just pause there and see if there's any resonance or comments.
Yeah, obviously a very interesting and important topic. I'm not an expert on pain or anything like that. The closest that we come to some of these ideas is our attempt to understand persistent physiological states as agents within the body, distinct from the material structures, the cells and tissues and subcellular components. I I really think that there's a lot to study in terms of the kinds of issues that we deal with, which is the competencies and disorders of morphogenesis. Yeah, so embryonic development, regeneration, aging, cancer suppression, metamorphosis, those kinds of things. And I think in all of these things, we still largely lack an understanding of agents that are persistent patterns, not physical structures, but patterns moving within the excitable medium of the body, which is more than the neurons. Neurons obviously are an excitable medium that store and process patterns, but so are all the other cells. They can do this as well at other time scales and in other modalities. But yeah, so we're very interested in some of those issues as far as what priors the tissues have and whether things like failure to regenerate is basically a persistent and in fact false belief among the collection of cells that they are not going to be able to regenerate properly. So those kinds of issues, I think we're just beginning to get a grasp on those experimentally.
My sense is that you have to look when you're studying another organism in terms of the physiological states from this pretty third person objective perspective. But when it comes to, I don't know, trying to approach the affect of some of these states, how might you approach something like that?
We want to understand how to modulate and impact those kinds of states and how they limit what's possible in the body. Well, oftentimes we try to think about things from the perspective of the state itself. So we too are a metabolic pattern, a temporary metabolic pattern, and we have mental states and memories and goals and preferences and thoughts and so on. And I think of all of these things as a continuum. James said that the thoughts are thinkers too. And this idea that it's a spectrum. We are also patterns, but we spawn off other patterns. And there's a continuum between fleeting thoughts and then persistent, intrusive thoughts that are a little harder to get rid of. And maybe they do a little niche construction in your nervous system to keep themselves around longer. And then much larger things like personality fragments, like in dissociative identity disorder, and then full human personalities, and then maybe some sort of transpersonal bigger things after that. I don't know. But all of these things, I see them all as a spectrum, which means that if you do have persistent states, it might make sense to think about what degree of agency do they have as a cohesive unit. What does the world look like from the perspective of the pattern itself as an active agent in the body?
In your work, Mike, talking about like memories themselves as kinds of agents that are good at being there and that are basically constructing their niche to persist. And so thinking of persistent pain from its perspective, as you're saying, as a kind of active inference agent, even I guess maybe somewhat more fearsomely in terms of the ability of pain to persist as a multi-scale competent active inference agent, where the prediction can play out on multiple scales and be reconstituted on multiple scales, but where that's not necessarily fearsome, but also an opportunity in terms of many opportunities to intervene. And I was just reading on this paper you shared, Max, on was it like the fighting monkey method?
Yeah.
Like different, and what you were describing earlier of like different ways you can send your pain body or the message that maybe it can relax some of its priors.
So one thing that's really interesting is that for my own experience with pain and a lot of people with pain is that it's not spatially continuous. And of course, you don't have to have that for you to call it an agent. But to what extent, I guess I'm curious in how we might differentiate between whether the persistent pain pattern over your whole lifetime is the agent, or do we say at different stages of time? Like, how do we map the continuity of that type of agent?
In my framework, the mapping any agent at all whatsoever is an empirical matter. So you formulate models of the agent, which include hypotheses about the size of its cognitive light cone. So
Right.
the biggest goal states that it can pursue, the space that you think it's working in, what those goals are, and then you do experiments and see what that gets you. And then from there, you revise your model accordingly. So I don't know. I don't think we can say ahead of time, at least I certainly can't, what that's going to look like. I think we have to do experiments, which is obviously quite difficult. But I think that's the only way to get it optimized.
Huh. One thing I also remember from the TAME paper is the notion that what unifies cybernetic agents is their goals and also stressors from the goal. So if you were to think about a persistent pain pattern as the agent, is the goal, it's hard to know exactly what goal this is, but some people suggest it's like distraction from some traumatic memory, or maybe its goal is like persisting over time, or it's multiple of those goals. Then would stressors be things that are removing the persistent pain pattern and it tries to not be eradicated?
It seems plausible to me. I don't think that mere persistence is as central or as unique a primary cause as standard evolutionary theory would say, that everything is about persistence. So I'm actually not sure that's really the primary biological imperative, but it's certainly a pretty plausible one. And it seems reasonable that whatever degree of agency some of these physiological patterns have, not being wiped out by various attacks, basically, which the various pain reduction techniques in effect are. Is if you're the pain pattern, trying to resist those and persist seems like a pretty high likelihood hypothesis to look at.
One thing that also comes to mind with Adam, your messages is this pattern of the social contagion of certain pain responses. There's there's this book, The Geography of Madness, that catalogs this, but I think one case was bulimia in Hong Kong. There was, in the 1980s, there was basically no one who reported it. And then there was a publicity campaign to try to expose it as a health problem. And it seems like that actually induced a lot of the behaviors and the patterns associated with that. And I guess you could also think about this as like a larger than organism agent through time. Yeah. But those seem much harder to empirically test. So.
Yeah, social contagion is interesting. We gave a talk just the other day about bioelectricity, showing the way that bioelectric patterns can be convincing or not convincing, and can spread. You can imagine the whole notion of an embryo is basically a kind of social contagion where all of the cells buy into the same vision of what they're going to do in anatomical space, and they're committed to they've got the same story about what they're going to do. And if you have cells that are descending from that or defecting from that story, you're going to have various teratomas and tumors and embryonic defects and so on. So in a certain sense, all goals are a kind of contagion among their parts. So there's going to be some top-down control where the collective, once it gets going, the collective itself, I think, it can shape the option space for its parts, but also there are going to be lateral effects. There's another, you can also look at, we discovered about a year or two ago now, this thing called the CEMA effect. CEMA stands for cross-embryo morphogenetic assistance. And there's this idea that we found, as a matter of experimental results, that large groups of embryos resist teratogens way better than small groups or singletons. And it's because the embryos are communicating, and we showed how they do it, but they're communicating to strengthen each other's commitment to a particular morphogenetic outcome. And being in a large group and doing that for each other is very helpful, and it can help them resist all kinds of teratogens and other things that would otherwise pull them off mission. We also, in that talk I gave yesterday, I showed some cool movies where there's a group of cells and they have a particular voltage, and then there's another cell over here and it has a different voltage and it's crawling around, and then it comes and it just barely touches, bang, and as soon as it touches, this cell acquires the same voltage as all the others, and then it walks over and joins them in some kind of mass that they're building. So this idea of, we have many examples of goal states, physiological goal states, which end up being transcriptional and ultimately anatomical goal states, propagating across tissues and being moved. And we have data. Memories, by the way, do this too. So if you have planarian flatworms and you train them to task, and then you cut off their heads,
right,
they will regrow a new brain. And guess what the memories do? It would migrate into the new brain and basically imprint on the new brain so that the animal can exhibit recall again.
Mm-hmm.
I think the whole social contagion thing, like everything else, goes across levels, goes all the way down.
One thing I'm confused about, and this might just be, I should familiarize myself more with some of your papers, but a lot of it seems like the unit of bioelectricity, you're often talking about it at the level of cells and cells communicating to each other. And I wonder because it's harder to do it at the level of an entire organisms, or once you get bigger, there's more chaotic effects. How do you think about cells versus organ systems interacting and the interfaces between them?
Yeah, I think the best model for this we have is polycomputing, which is this idea that there are multiple overlapping, interpenetrating agents within the collective at different levels, different scales, and they all have their own interpretation of what's going on. So, for the vast majority of what we do in bioelectricity, we are not talking to individual cells. The messages we send are meaningless to individual cells. They are interpreted by the collective as a large scale, I would say, tissue level scale of some size that we can experimentally derive.
When you use the optogenetics to change the sodium channels and the electric patterns, though, that is at the level of a cluster of cells or an individual cell, right?
Yes and no. Physically, no matter what anybody does, if you wanted to zoom in to the level of molecules or cells or anything else, you can. You and I are having a conversation right now, and if somebody wanted to describe it at the level of air molecules moving around, you could, and you would say, what do you mean? It's all physics. There's nothing but physics going on here. I can see all the molecules move. It's just physics. So you can always do that. But the real question, I think, is what is the level at which you can cash out a model of interpretation that gives you the most fertility as far as new experiments. So if we had a conversation and somebody gave a physics description of the air movements, like not exactly wrong.
It's ridiculous, yeah.
But certainly not as fertile for understanding what's actually going on and thus doing new things like having a conversation themselves. It wouldn't be helpful. So the same thing is true here. Yes, you can track down what individual cells do, or in fact what the individual proteins do when they get hit by light and all that kind of stuff. But the interpretation, the useful interpretation here is actually at the level of the collective, because when we modulate the patterns that two things. When we modulate the pattern, first of all, it really doesn't matter which cells precisely we hit. It's very forgiving in terms of those kind of low-level details. It's very coarse-grained over that. We know it doesn't matter which ions we use as long as we get the voltage right, and voltage is a very coarse-grained system-level parameter. And more importantly, the message that we transmit is, for example, build an eye. No individual cell knows what an eye is. It doesn't make that message has zero meaning at the level of a single cell, but it does have a meaning to a large region that actually can make an organ. You could say that, oh no, the message you gave was there's a photon here, or the message was be depolarized at this region of the cell membrane. But my claim is those are not exactly wrong, but they're completely useless for figuring out how to design therapeutics like that. If you want to design therapeutics, you have to understand how is the collective interpreting that message, and why is it going to be an eye versus a limb versus a heart. That's where the specificity of the message is.
Okay, got it. Adam, do you want to say something about body keeping the score in terms of morphological predictions and whatnot?
You could try. So yeah, so it seems like I think I'm probably like begging some questions in terms of like what's higher and lower, but still the idea of a control hierarchy and moving across maybe abstraction layers, but like levels of organization as you move from like cells to tissues, but different that the prediction could play out. And you mentioned this, for instance, earlier communication about like the prediction at the level of fascia or like the vascular system, but just the way you have like muscle tension in the body itself is a kind of prediction about like where you would be in the world. But you could also have not just like the way the body is shaped in different ways and like the physical mechanical system, but like the way the reflex arcs are assembled, that like the stance, are you like guarding yourself or not? And you might not even know you're doing it. You might be like bracing for a blow or something without realizing it, trying to like protect yourself, or like trying to like, but like cutting yourself off and not realizing that's what's happening. Or it might be like explicit belief. And on some level, you know, like when I've lived with many periods of my life where like I've lived with chronic pain for a while, and there's like a certain sense that you almost become identified with it in a way. It becomes like part of your self-concept. You're almost like attached to it. And so it's like there's this like multiple levels where like the pain engram agent can reconstitute itself. And I guess I was also wondering, like you're mentioning social contagion. I was wondering like the different levels at which like we can couple with each other and transmit our emotional states. Like, so it's like, you know, the bulimia example that could happen at a very high level. I don't know, again, that question, higher level, but like a level of the way you schematize yourself and like some sort of something you could talk about, but also like the way we might couple just in like the way we like hold ourselves like when we're together and like subtle like motor entrainment or chemosensing entrainment, even like what sort of like odors we're sharing, or I don't know, to what degree do we have potentially bioelectric field like coupling? Anyway, so I was just thinking about like the different levels at which like pain engrams can reconstitute themselves and be transmitted, and like seeing how these different levels they can it could play out at any of these levels that are all coupled.
Yeah, that reminds, that's what we call a lot of parts of culture. And it reminds me of this anecdotal observation by some some teachers, some meditative teachers, that if you go to different cultures and you ask people to point where they feel that their self is located, like there's a different pattern. Apparently in Asia, the self tends to be located more in they point to their heart or their chest, and then in the West, people tend to locate themselves in their heads. And I don't know how empirical that is, but yeah, it feels like that is an important and useful question to ask, the social element of this. One question I have is the degree to which pain is the right word to even talk about these things. Because I really like in your work how you try to move away from this consciousness question. And you say we probably can't understand consciousness before we understand cognition. And I've had this experience and I'm calling it pain, but it feels like it's just such a nebulous term that people have really, it doesn't feel actually that useful in many ways. And I wonder how you might think about the language or articulating different ways of thinking about the phenomenon I'm pointing to.
Yeah, I don't know, boy. That one's a little beyond my pay grade. I'm not sure. I'm not sure what I can say. Language, in any case, is a very late coming add-on to all of this. So I would think that the earliest pain is the initial depolarization of a microbial cell being penetrated with damaged by something that causes the voltage gradient to collapse and thus depolarize. And I think that's probably the first painful event. And as far as the consciousness goes, my perspective is that it goes all the way down. So I think that was actually a bona fide. The first time that happened, that was a bona fide painful event.
So the paramecium fleeing.
Yeah, 100%. Paramecium to me is a no-brainer. I'm concerned about much lower levels than that that are, I think, the harder cases. But the paramecium, I think, for sure is having a pain experience. But yeah, I don't know what to say about language and how it gets put on top of that.
Okay, so what's funny is that I had this sense, the basic evolutionary story in my head was like paramecium, and maybe a little bit before that, when there's this reflex arc to retreat from a potential source of damage. That is the foundation of everything we're calling pain, and then all of this circuitry. Like the Urbilateria added more complex motor responses to flee and to coordinate. And then when there was more, when animals were in a more social context, then some of the machinery for affective response and theories of mind came to play, and that added a dimension to this pain-like experience. But it sounds like you want to extend that even more before paramecium. Would you alter or question any of the narrative that I just described?
Yeah, the way I see it differently is that the story you just told, which is certainly the plausible conventional story,
Yeah.
is very focused on embodiment in the three-dimensional world. So when you're saying it runs away from the pain, yeah, it moves physically through physical space, and that's fine. But I think biology was navigating many other spaces long before it could move through physical space. So there are desired and undesired regions of metabolic space, physiological state space, transcriptional state space. And I think that many things that we think of as completely immotile, disembodied, whatever, are actually navigating lots of other spaces that we just have a hard time visualizing. So doing this perception, decision, action loop in other spaces. So I'm interested to know what transcriptional pain looks like, what is happening in a gene regulatory network that is being chased into a region that has negative valence for it. And admittedly, these are all very much work in progress types of things to be able to cash that out. But I don't think it's just an issue of conventional physiology and then motility. I think those are just obvious instances of a much broader set of phenomena. What does it take to punish a molecular network? Well, when it's in paramecium shape, it's pretty clear what to do. But in other embodiments, those same molecular networks, we don't really know. And our tendency is to say that's impossible. Chemistry doesn't have valence, it doesn't care. But obviously some kinds of chemistry does. And I just think we have a very narrow view of what that is.
Yeah. And one thing that just strikes me with what you're saying about the patterns themselves being agents is the first time there is a capability, we can go back to transcriptional studies, but even with the paramecium, the ability to respond, can you say that's like the first instance of a new type of agent appearing in our evolutionary timescale? This is like this like pain-like agent. And and then that, like, when it's out of the range of imminent danger, then the agent goes away. Is that, I guess the question is, does that yield experiments?
Possibly, yeah. We got to do experiments. So the only thing I'm sure of in all of this is that these things are not to be answered with linguistics or philosophy like this. We have to do experiments here. So I don't know, but it feels like a reasonable hypothesis for sure. And yeah, the origins of valence in unconventional embodiments is a really critical and fascinating aspect.
And how might you address someone with a more conventional stance that, oh, you need this certain neural circuitry or neural somatic circuitry to experience affect? What do you think might be convincing to maybe the majority of people that believe this?
Look, if I had a knockdown argument for that, that would be great, but obviously we don't. However, my intuition would be simply this. I would say, look, in the greater universe, and I know some people's intuitions obviously on this obviously differ, but I feel like it's, for me, the higher probability priors that the universe is probably filled with all kinds of very weird and wild kinds of life. And I think that it is completely implausible to me anyway, that in the whole universe, the only creatures that actually feel pain are the ones that have our precise kind of neural architecture. I think so that seems crazy. If some alien landed on your front lawn and came out and said, "Oh my God, this is a long trip. I got such an ache in my tentacles," you say, "No, you don't have the same. You're just a philosophical zombie." That seems crazy to me. And if that's the case, then we can take the next step and say, okay, fine. So if it's not the same neural structures that we have, what is it then? And as soon as you crack that door open, then all bets are off, because then it's all about goal directedness and where do goals come from in the first place and all those questions that I've been poking at.
I like the sci-fi story that you mentioned, out of the dense being seeing Earth creatures just appear and disappear in 100 years and questioning whether those patterns are sentient or have affect. To swap to a little more of a pragmatic lens, it strikes me that psychotherapies do something important. We don't seem to have tools to really express or to try to capture what's going on. And the RCT, the randomized control trial that we use to try to test the efficacy of a particular drug, it does not seem to make very much sense when you think about the interaction between a therapist or a practitioner and the modality supposedly that they're using and the patient. And given TAME and given your perspective, I know this is outside of the usual wheelhouse, but how might you think about trying to understand this at the level of human therapeutics, non-pharmaceutical therapeutics?
Two things come to mind. One is this notion of a therapeutic alliance. So my understanding, and again, not an expert on this, but my understanding from talking to people is that one of the most predictive aspects for therapy, like for all, I think many different kinds of therapeutics, is the alliance and the belief on the part of the patient that the
therapist cares about them.
That they're going to be helped and all of that. And that leads to the other super interesting to me area, which is placebo and nocebo effects. So Fabrizio Benedetti has this amazing phrase that he uses. He says, words and drugs have the same mechanism of action. And I think that's, and his work and other people in that field, that's super, super interesting and important, that the mechanical biochemical story, much like we were talking about a minute ago, of why certain drugs work and don't work, may be largely at the wrong level, and that the actual explanation might be some much higher level thing that has a lot more to do with the expectations and the beliefs, not necessarily of the patient at the human level, but of the tissues of the patient, of the physiological systems of the patient. Like we have a minimal example of placebo effects in molecular networks. You can do a placebo in the molecular network, because in terms of associative conditioning. So I can do associative conditioning of a drug that actually, of a stimulus that actually triggers a particular response node, together with a neutral stimulus that doesn't do anything. If you pair them, the system eventually learns that they're associated, and then you can induce the effect just with the neutral stimulus alone. Now that's a kind of placebo, because in effect, you got a stimulus that actually doesn't trigger, isn't a trigger response, but because of your past history, you now believe that it does, and therefore it does. So that work, the papers on the Pavlovian conditioning or associative conditioning in GRNs, I think it is a minimal model of a placebo. And if a 5-node molecular pathway can do it, then obviously humans should be subject to it. So
I think that the Therapeutic Alliance, I'm semi-familiar with that literature. And in my more anecdotal experience, there feels like a really big difference between how people approach it. And there's a lot of stuff that's not just the Therapeutic Alliance. But I'm wondering if you have heard of internal family systems, the therapeutic models. It's Minsky's Society of Mind, but trying to heal people. And to me, that seems we're taking the level of agency, sub-unitary agents, and we are trying to have this discourse and unify them. And that process of unification leads to more coherence and like a greater level of settledness. Yeah, that seems like one instance where you're applying like a TAME-like thinking to this therapeutic intervention.
The first time I saw it, and Alexei Tolchinsky was pointing out to me that it's not new, and that this kind of idea has been around under other names for a while, which I don't know anything about, but he did. Well, the first time I saw it, it looked like, oh, this is polycomputing. This is a polycomputing frame applied to your own behavior, which, like any good frame that captures what's going on, it makes it more effective to do what you need to do on the system level. So it seems quite plausible.
And then what I'd also add is there's an interesting set of bodily modalities or somatic therapeutics. Have you ever heard of the work of Moshe Feldenkrais?
No, it doesn't ring a bell.
He was a physicist, a cyberneticist who later turned to motor learning and how to heal people. He was in the Francois Joly-Curie's lab, and he was the main engineer for their experiments in radioactivity. But he had a really bad knee injury, and in the 50s and 60s, he swapped from being a physics professor to studying motor learning and how people can basically heal and coordinate their limbs better. So there's now this pretty famous within certain communities method called the Feldenkrais method, where it basically looks like you are lying on the ground or sitting in a chair, and you pay very close attention to gentle movements that you make. And the act of paying very close attention causes the body to reorganize around making those types of movements more easeful. And so what struck me as I was reading the TAME paper in the section on regenerative medicine was that's like a decades old instance of this type of internal alignment or trying to create larger coherence in the system. And we haven't really studied it, or it feels like we don't have the tools to really study that. But that's another example of, I felt like, TAME being useful.
Yeah. I think that's reasonable. We have certain results that kind of look like they might be. So, for example, in the leg regeneration work, like in the frog leg regeneration work, typically adult frogs don't regenerate their legs. So we put on this wearable bioreactor that has certain payload of drugs to convince them to do it. But one of the cool things is that even an empty biodome has some effect. And I suspect that what's happening there is that what we're providing with an empty biodome is a degree of agency for the cells over their environment. It's a very small, contained, protected milieu where any molecule that cells put out, instead of floating off into the infinite bath of the frog tank, is actually constrained in that space and is still there for the cell to read. And so I think over time, the cells can feel that, oh, wait a minute, this is a protected environment in which what I do matters. And therefore, it makes sense to put some effort toward regeneration, as opposed to if I was just waving out there in the harsh world and I was going to get banged around on various objects, I'm never going to regenerate anyway. Why even try? Why spend the effort to regenerate? So I have a feeling, and we haven't proven this yet, but I have a feeling that what's happening there is the degree of safety and control that you're providing for the cells is step one. You got to get them that it's even possible to, that it's feasible for them to regenerate. And then you might want to do some other things. Yeah, that's that. I think those things are going to end up like getting buy-in from the physiological networks as opposed to trying to force them. Ultimately, to me, is the road to therapeutics that actually work in a permanent way and not exhibit so many weird off-target variable effects as the cells are trying to fight what's an obvious hacking attempt to try to force it. Yeah, I don't know exactly how that intersects with pain, but I think these are all related issues.
Yeah. And what I was actually just going to go where Adam was commenting about joint actions and also this idea of TAME as applied to health. So one of this preprint that I wrote with my movement teacher was just basically an exercise in what happens when we try to think more seriously about health as you might call intelligence in different problem solving spaces. And this is I'm especially interested in this at the level of an individual and where you want to orient and go and solve problems. And I wonder if you would add any refinement or specificity to the types of problem solving and the types of spaces that we might call healthy. Because right now it's like I think it's a very generative idea that we can how our vestibular system solves problems is really important, and so is how our liver solves problems in this metabolic space. But how can that be brought forth and translated into something that's maybe more like practically guiding for the medical industry?
Yeah, that's interesting. I think it was Martin Picard who we had a whole day symposium at some point earlier in the year around what is health, trying to define the notion of health. So I think that's non-trivial entirely. But the way that we are addressing the biomedical aspects is as part of more broadly the diverse intelligence agenda, which is to develop translation tools to communicate with unconventional beings. So I'm very interested in producing tools that help diverse minds communicate with each other, even though they inhabit different spaces, and we're talking very broad. So
like liver could be a diverse mind.
Oh, that's just the start of it. So yeah, so talking to your organs, that's actually a project that's in the lab now, using AI to develop a way to communicate with your organs and ask questions and hopefully give instructions and things like that. Instead of, hey Siri, it's going to be, hey liver, why do I feel like crap? Let's talk about my potassium balance or whatever.
So how about like in the improving interoceptive ability? Some people can have incredible interoceptive ability. They can sense like very specifically where there is tension or where their organs might be feeling different. It seems like that's worthy and interesting as an avenue to explore too.
For sure. And we don't have any facilities here to study the natural human case. But what we are interested in is to develop tools to allow anybody to do that. So the idea is there should be a scan that isn't scanning molecular states, it's scanning affect of your various body organs. Like, how is the liver actually feeling? And so on. And I think part of the issue here is that I have my suspicion is that there needs to be an impedance match between what you're looking for and the tool that you're using. Like, the reason that physics doesn't see minds, it sees mechanics, is because it uses low agency tools, voltmeters and rulers and things like that. If you want to see minds, you need to have a mind as a detector of it if you want to see those kinds of things. And
wow.
So that means that if we want to read molecular states, great, you'll have a molecular test and you'll learn about molecular things. If you want to learn about priors, beliefs, counterfactual thoughts, and whatever, to whatever extent the different organs have that, we don't know, but no doubt some, then you're going to have an agential sensor on the front end of it, which might be AI, it might be a biological. We're working on that now. And Adam points out something interesting, that the first thing we found anthrobots to be doing is healing other cells. So the first thing we found is that anthrobots actually will heal neural wounds in vitro. all of these things have capabilities. And who would have thought, right? These are your tracheal epithelial cells that apparently have the capacity to form a motile little being that will heal other types of wounds. So I think the degree of healing potential is probably enormous. And we are just extremely mind blind in our hyper focus on chemistry, the level of chemistry and so on. We're just totally bad at communicating with all these things. But I think we can get better.
That's very moving, actually, the brethren healing each other. And what you just said about that's an incredible thought. Thank you for sharing that. The impedance of the tool and the thing being measured. Then that's what you were saying in the TAME preprint about there being a blurring between first and third person science, because third person is this pretense of the thing you're measuring doesn't have its own perspective, or the thing you're using to measure. I'm not sure how real this is, but one thing that I'm recalling is that in certain traditional Chinese medicine circles, there are people who reportedly can generate bioelectricity. There's a few cases I'm aware of people talking about being able to affect tumors as they put their hands and they cause the tumor to shrink. And it seems at least naively plausible that there is some kind of unifying thing, or you're basically convincing those tumor cells to become part of the whole again. And
we don't know, right? So in those cases, and I know what you mean there, and there are all kinds of data going back a long time, improved cardiac scars and immune system function and all kinds of cancer, yes, all kinds of other things being affected that way. In the case of cancer, in that scenario, I actually don't know what's happening to those cells. Are they normalizing and joining the normal collective the way that we have done in some of our cancer therapeutics, or are they being killed off, cleared off? Like, we don't know. I'll tell you that, and again, I don't know how any of this works exactly, but what I've heard from people who do this kind of work, from the healers who do this kind of work, what they say is that it is less effective to visualize, okay, the bacteria are going to be dead, I'm going to kill the bacteria. That is less effective than visualizing something, I forget how they put it exactly, but for the benefit of the entire system, just do whatever is good for you. And that seems to be more effective. And I don't know how any of it works, but it really matches our experience in the regeneration arena, because we can, for example, we can try to micromanage genes, cells, tissues. That's a lot of effort, and it usually goes wrong, and you get all kinds of mismatches and so on. What works very well are very high level signals that say, just build whatever normally goes here. I'm not going to try to tell you what it is. The amazing thing is that the bioelectric trigger to regenerate a tail in the tadpole is exactly the same as to regenerate a leg in the adult frog. And I've never seen a tail form where the leg goes or a leg form where the tail goes. We do not tell it what to build. The most effective intervention we found is a signal that just says, build whatever goes here. So I find that parallel, right, where you're leveraging as much as possible of the natural competencies of the system. You are not trying to force it. And I think that's the direction we want to go from the molecular approaches, where you really try to be in charge of all the microstates, to the much higher levels where you can hopefully just let the system do what it already knows how to do. But of course, the devil's in the details of how to do that in the general case.
I was just thinking with the case of cancer that you were bringing up. So it seems like one model that's coming to mind is, so if for whatever reason the cells in the tumor are getting the message that like things are not copacetic, the cybernetic entropy of the collective is not being managed, they become like untrustworthy and like defect on the ancient alliance and say, I'm not going to constrain my growth. I'm going to make a break for it, take as much as I can, or not even think that's like their cognitive light cones constrict and they start seeing the rest of the agent as like an externality. But if you can somehow, by whatever means, help the cells to feel safe again, feel like trusting, then maybe they can come back into the fold. And so like somehow, I don't know so some sort of like spiritual master comes to you with this like benevolence and confidence. Maybe they can, whether it's via the quality of their bioelectric field or by maybe multiple levels of entrainment, like I could see potentially that having, we need to just figure out how to scale that and just create like an army of spiritual masters to go around the world, like laying their hands on people then.
Yeah, so that's very interesting, right? In our approach, what we do is we functionally reconnect the cells to their neighbors. And in a way, it's like what you're talking about, that as soon as we force that aspect of it, suddenly It's, oh, I'm part of this mind meld again. Of course, I should be building a kidney. Why would I be trying to crawl off as an amoeba? This is clearly what I should be doing. There's a danger here, which is that a lot of people, so what I probably should have foreseen but didn't, is that a lot of people read my take on cancer and they immediately project it into the social sphere and they email me. I get one of these per day solid. Somebody says, oh, I got it. I saw your thing about cancer and I know what we need to do. We just need to Borg ourselves together into this giant like human syncytium, and then life will be good. No more selfishness, no more antisocial. And I'm like, listen, that's been tried repeatedly. It always leads to the same way, which is the horror. And you can't just project these things into this human sphere, because you end up with a gap junction, exactly, some sort of human gap junction. People ask me this constantly, and I get it, but the problem is that you will get a larger collective that does new things, but as we've seen, that larger collective really doesn't care about the welfare of the parts any more than our body is upset at when you go, and I always use the same stupid example, you go rock climbing, you have a fantastic day, but you leave a bunch of your skin cells on that wall, and who's worried about them? They weren't asked what was going to happen to them. And this is right. So I don't know whether there's a version of this that is relevant for the greater kind of larger scale for humans, but it is not going to be by giving up the autonomy the way that cells do. I'm not a fan.
And it strikes me also that there's probably new types of, you might call them parasitic or at least non-sympathetic agents that arise in the new interface and that can hijack the whole in a different way when there are gap junctions. Like you need a different type of immune system when you're scaling novel agents, I would imagine. Okay, given that we have a couple minutes left of the time, I was wondering, so in terms of the current research that I'm doing, I'm very interested in what is this minimal agent that can characterize, using active inference, you could say associative learning, or this like placebo effect, and translates over time, we might call that chronic pain. I'm wondering if there are questions that you think are interesting to ask in this computational domain about this. One that you mentioned already is this physiological state. Can we model pain as an agent itself? But yeah.
Yeah, right. To me, some of the most interesting things would be a model of agents doing active inference, whatever, but then looking at that system to see if we can identify novel emergent perspectives. Are there patterns? We just, so I'm going to put it up, the link shortly, something just that got accepted from us on the interaction between economic game theory, the prisoner's dilemma, and things like that, and morphogenesis. And one of the things you see when you do these kind of simulations is that, there are large scale patterns that show up that are not overlapping with where the boundaries of the physical agents are. You get these novel things. And what is the perspective? What is their perspective? I think that would be very interesting to check. I apologize. I've got to be at another meeting, but thank you. This has been fun to think about this stuff, and I'm happy to talk again at some point and see what can actually be done in practice.
Thank you so much both for your time. Have a great rest of your day.
Great to see you. Thanks. See you, Adam.
Bye. If you're interested in better understanding pain and learning practices for how to work with it, check out our resources at debugyourpain.com. The link's also in the show notes. If you're interested in better understanding pain and learning practices for how to work with it, you can check out our writing and resources at essays.debugyourpain.com. The link's also in the show notes. Thanks for tuning in.